Hi. In this section, we talk about Ingress. Let's start with why we need ingresses. We have introduced services, which forward requests based on layer 4 TCP and UDP protocols. Ingresses can forward requests based on layer 7 HTTP and HTTPS protocols, and allow you to specify domain names and paths for forwarding. As shown in this figure, after your request reaches the ingress, it can be forwarded to different services based on the domain names and paths you set, and finally to the target pods. This is how an ingress works. To use ingresses, you must install the Ingress Controller in your Kubernetes cluster. Ingress controllers can be implemented in several modes. A common solution in the community is Nginx Ingress. Different cloud vendors provide their own implementations. For example, Huawei Cloud CCE uses the Elastic Load Balance Service, ELB for short, to back ingresses. Logically, an external request is first sent to the Ingress Controller. The controller searches for the backing service based on the defined ingress rules, finds the endpoint, and forwards the request to the pod. This is the workflow. In our demo, we will show you two types of ingresses. The Ingress Controller is installed on the master node, which is automatically installed when you create the cluster. When you create an ingress, the command is sent to the API server of the master node and then to the Ingress Controller. Then, the controller converts some configurations of the ingress into access policies of the ELB load balancer. Actually, the controller calls some ELB APIs and configures the policies to the load balancer. From the perspective of the access traffic path, the request reaches the load balancer first and then the node, based on the rules. The service is behind the node, and your request is then forwarded by the service to the pod. This is the default Ingress controller of Huawei Cloud, which is implemented based on the ELB service. CCE also supports Nginx Ingress, that is, the open source, commonly used Ingress controller. The Nginx Ingress controller is installed on a worker node. When installing such a controller, you need to bind a load balancer. The configuration is as follows. You initiate a request for creating an ingress. The request is sent to the API server and then forwarded to the Ingress controller. Then, some rules defined in the ingress are converted into the Nginx configuration. From the perspective of traffic access, the traffic first passes through the load balancer and then reaches the Ingress controller. Then the controller reads the newly defined configuration and forwards the request to the target pod. There are some differences between these two types of ingress controllers. First, the ELB Ingress controller is installed on the master node and the Nginx Ingress controller is installed on the worker node. Installing the controller on the master node will spare your worker node resources. The other difference is that the Nginx Ingress controller cannot be bound to multiple load balancers, but the ELB Ingress controller can. That is, you can configure a load balancer for each rule. Now, let's look at the definition. Creating an ingress is similar to creating a service. The first is the API version, and then the kind and metadata. The metadata defines how to work with ELB. The configuration is stored in the annotations part. For example, we create a shared load balancer, corresponding to the union class. The ingress class parameter specifies the type of the ingress controller to be used. In CCE, setting ingress class to CCE means you use the ELB ingress. Then, you need to specify the ELB load balancer port and parameters for auto creation. The configuration is the same as that in the service. The following parameters reflect the desired state of the ingress. Configure the rules such as the host, protocol, path, service, and URL to match. This is the definition required for creating an ingress. If you want to create an Nginx ingress, simply set the ingress class to Nginx. And skip the creation of a load balancer. Because the load balancer has been bound to the ingress controller when the ingress controller is installed. The Nginx ingress just uses that load balancer. Then, you can use the load balancer address to access the load balancer. Other parameters are the same. This is the definition for creating an Nginx ingress. In addition, pay attention to the version used by the ingress. You can choose from V1 Beta 1 and V1. The V1 version is supported from Kubernetes 1.19. In CCE, this version is supported from cluster version 1.23. The differences from V1 Beta 1 to V1 include: first, you set the ingress class in spec, not annotations anymore. And second, the field name is changed to ingress class name. Also, the backend settings. In the beta version, you set two parameters. In the V1 version, the name and port parameters are placed under the service field. They still function the same, just defined in a different place. In the V1 version, you need to specify path type for each rule. You can choose from several types. You can refer to our documentation for more details. Now, let's see how to create an ELB ingress. Copy the example YAML file. Change the service name, for example, set it to Nginx node port. That's the service we created. Then, change the bandwidth name. Save the settings and create the ingress. Check whether the ingress is successfully created. We can go to the CCE console, and you can see the ingress, along with a load balancer, is created. In this way, you can access the ingress using its load balancer IP address. There is a public network address. You can use it to access Nginx. This is the use of ingress. Next, let's see how to use Nginx ingress. First, you need to install an add-on named Nginx Ingress. When installing the add-on, you need to set some parameters. For example, the requested resources to use. We can reduce the quotas because we are just running a demo and the cluster does not have many resources. The next step is to interconnect with a load balancer. You can interconnect with an existing one or create a new one. We create a load balancer. Note that the selected load balancer and the cluster must be in the same VPC. Otherwise, they cannot communicate with each other. The bandwidth can be adjusted to a smaller value. The name can be set to ELB Ingress. After the creation, go back to the CCE console and refresh the list. Then, we can select it and install the add-on. It takes a few seconds to install the add-on. After the add-on is installed, we create an Nginx ingress. Copy the example YAML file and change the service name to Nginx node port. We need to change the name because we have already created an ingress with this name. Let's try again. The query result shows that there are now 2 ingresses. Let's go back to the console. You can see that the ingress is in the normal state. Then, you can access the ingress. First, you need to find the public IP address of the load balancer. Copy the address and paste it to the address box. This directs you to the backend Nginx and your access is successful. In addition to using the command line, you can also use the console for creation. First, set the name. Then, decide whether to interconnect with Nginx. If you select this option, you create an Nginx ingress. Let's look at the YAML file. You can see the class is now Nginx. If you deselect this option, the class will be CCE, which means you create an ELB ingress. Each ELB ingress can independently connect to a load balancer. The following parameters are the listener and forwarding policy settings, for example, the service to which your request is forwarded. This is pretty much the same as you define a YAML file. Okay, after demonstrating the creation on the console, let's look at how the ingress works with the load balancer. Back to the ingress list. Click the load balancer name to go to the ELB console. You can see a listener is created with a specific forwarding policy. The description here says the listener is automatically created by the CCE service. In the forwarding policy, you can see what we have configured, for example, a / as the forwarding URL. Then, on the Backend Server Group tab page, you can find the nodes in your cluster. If you access the load balancer, it forwards your request to the backend server. If there are multiple servers, the load balancer selects one of them based on the forwarding algorithm. You can see the server uses port 30,000. Actually, it is the port of the service. We defined this port when creating the service. The ingress has written all policies to ELB. If you access the load balancer, you will directly access port 30,000 of the backend server, which is equivalent to accessing the service. As you will configure a label selector for the service selects a backend pod and forwards the request to the pod. This is how you use an ELB ingress. Let's check out the Nginx ingress. It has two listeners, listening on ports 80 and 443. Port 443 is used for HTTPS requests. In the forwarding policy using port 80, the backend server is the same as that of the ELB ingress. However, the Nginx ingress is not using the port of the node port service, but the fixed port of the Nginx Ingress Controller. On the CCE console, you can find where the port is defined. When you installed the Nginx Ingress add-on, CCE creates a service. In the service YAML file, you can see a parameter named ports under the spec. The one called HTTP uses port 80, and its corresponding node port is 31,363. The other called HTTPS uses port 443, and its corresponding node port is 31,046. To view the configuration file of the Nginx controller, you find the namespace and workload in which the controller runs on the workload page of the CCE console, and run the git pod command to access the workload. First, we query the workloads in the target namespace. You can see that there is an Ingress controller. Let's access it. Find the configuration file and view the details. This configuration file contains so much content. If you are familiar with Nginx, you can directly locate the server parameter. Under this parameter, there is a location, which is the URL we configured. A /. All related configurations are written here, such as the ingress name, backend service, and service port. When you access the ingress, the controller reads the configuration file and forwards your request based on the configuration. This is how an Nginx ingress functions. The last point is the services that ingresses connect to. Different ingresses have different requirements on backing services. The ELB ingress supports only node port services. The Nginx ingress supports cluster IP and node port services. Different ingresses also use different load balancers. Dedicated load balancers support pass-through networking. If a pod uses an Elastic Network Interface, or ENI, requests can be directly forwarded from the dedicated load balancer to the pod. This feature is closely related to CCE turbo clusters. We will talk about it later when we introduce CCE turbo clusters. That's all for ingresses. Thank you.